Good morning all. So in today's class we will move on to the first module of combinatorics. So in first module we will be mainly seeing permutations and combinations and how they can be applied to a variety of problems. So before moving into permutations and combinations, we will look at two basic principles of counting. So every counting technique is somehow coming from these two basic principles. നമ്മൾ permutation combination എടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ അകത്ത് വരുന്നത് ഈ രണ്ട് പ്രിൻസിപ്പിൾസ് ആണ് മെയിനായിട്ട്. സോ ദാറ്റ് ഈസ് അഡീഷൻ പ്രിൻസിപ്പിൾ ആൻഡ് multiplication principle. So let us look at what is called the addition principle. Now addition principle അത് നിങ്ങൾ ഓൾറെഡി കണ്ടിട്ടുള്ളതാണ്. നമ്മളത് വെച്ച് ഒത്തിരി പ്രോബ്ലംസും ഒക്കെ ചെയ്തിട്ടുണ്ട്. സോ it basically tells us what is the number of elements. So if you look at the form of set theoretic way, so if you have k sets a1 a2 etc, ak, and if they are disjoint, so we all know what is the cardinality of a1 union a2 union etc ak. So a1 union a2 union ak means that is at least one of the event a1 a2 ak must occur. So that is, so in addition principle we mainly look at the number of ways in which at least one of the event occurs. So either e1 or e2 or e3 or ek. So at least one of the events occur. Adinte count aanu we get in the addition principle. So if you have events e1 e2 ek of this form, so you have an event e1 which occurs in n1 ways and e2 which occurs in n2 ways and ek which occurs in nk ways, then the number of times or the number of ways in which at least one of even e2 or ek occurs is n1 plus n2 plus etc nk. So for example, so let us see a very simple example. Suppose you have two destinations a and b. Okay, അപ്പോൾ a നിന്ന് ബിയിലേക്ക് പോകണമെങ്കിൽ so you can use either the road transport. Suppose there are different alternative routes. നമ്മൾ പോയിന്റ് എ നിന്ന് പോയിന്റ് ബിയിലേക്ക് പോകണമെങ്കിൽ alternate routes ഉണ്ടാവും. അപ്പോൾ let the number of road routes that will be equal to 3. മൂന്ന് റൂട്ട്സിൽ നമുക്ക് എ ടു ബി അപ്രോച്ച് ചെയ്യാം. ഇനി suppose you can go via C. So there is two ways of going via C. Then suppose there is say 4 ways of going via air transport. Okay, so these are the different ways in which you can go from A to B. So the first one is the event E1, then the second one E2 and E3, which can be done in 3, 2 or 4 ways. ഇപ്പോൾ നമുക്ക് A to B പോകണമെങ്കിൽ നമുക്ക് മൊത്തം 9 വേസിൽ പോവാം. Okay, there are 9 options to go from A to B. So either by road, either by S or either by air transport. So that is a simple example of addition principle. So the addition principle says that, so assume that there are n ways for the event e1 to occur and 2 ways for the event e2 to occur and nk for the event ek to occur where k is greater than or equal to 1. So if these ways for the different events to occur are pairwise disjoint. So here going via road is independent of going via the sea transport, which is independent of going via air. So these are pairwise disjoint. Then the number of ways for at least one of the events e1 or e2 or etc ek to occur, that will be the sum of all the ways. So it will be n1 plus n2 plus etc nk. So that is summation I equal to 1 to k n I. So ഇനി നമ്മൾ set theoretic notation പറഞ്ഞ പോലെ, so here you have pairwise disjoint sets a1 a2 etc ak. so pairwise disjoint ആകുമ്പോൾ ai intersection aj is not equal to 5. so here we are looking at the cardinality of a1 union a2 union ak. so the cardinality of a1 union a2 union ak will be the sum of all the cardinalities of the set. So that will be summation I equal to 1 to k cardinality of ai. So this is the union of all the sets a1 a2 etc ak. so this is the number of elements in a1 or a2 or etc ak. so that is the addition principle in the set theoretic form. അപ്പോൾ നമ്മൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ നമ്മൾ രണ്ട് രീതിയിലുള്ള നോഷൻസും യൂസ് ചെയ്യാറുണ്ട്. സോ ലെറ്റ് us see an example of addition principle. So the question is to find the number of ordered pairs xy of integers such that x square plus y square is less than or equal to 5. So you need to find all the integers such that x square plus y square is less than or equal to 5. X square plus y square, that will be always greater than or equal to 0. So less than or equal to 5 nu parayumbo you have the possibilities that it is equal to 0, 1, 2, 3, 4 and 5. So let us divide all these options to 6 cases. So let us take 6 sets here. So Si, let Si be the set of all xy such that xy belongs to z and x square plus y square is equal to I. So I will be equal to 0, 1, 2, 3 up to 5. Now the first set S naught ennu parayunnu, that is set of all xy such that x square plus y square is equal to 0. So that happens only when you take the point 0, 0. അപ്പോൾ അതിനകത്ത് ഒരു എലമെൻറ്റേ ഉള്ളൂ. ഇനി അതുപോലെ S1 എന്ന് പറയുന്ന x square plus y square equal to 1 ആവണം. So that happens when you have 0, 1, 1, 0, then negative വരുന്ന 0, -1 and -1, 0. So there are 4 elements in it. ഇനി അതുപോലെ S2 എന്ന് പറയുന്ന സമ്മ് x square plus y square 2 വരണം. അപ്പോൾ 1, 1, ഇനി അതിൻ്റെ നെഗറ്റീവ് വരുന്ന ടേംസ് എടുക്കുക. അപ്പോൾ 1, 1, -1, -1, 1, -1, -1, 1. Again there are 4 elements in the set. ഇനി S3 will be an empty set. കാരണം x square plus y square, you do not have a choice of integers such that x square plus y square is equal to 3. ഇനി next is x square plus y square equal to 4. അതിന് 2 square എടുക്കുമ്പോൾ വരും. So 2 square or minus 2 square. So that again gives 4 values, 2, 0, 0, 2, -2, 0, then 0, -2. ഇനി S5 അതുപോലെ തന്നെ 1ഉം 2ഉം, so positive and negative. So that gives for S5. So S5 there are 8 points. Okay. So we have got the number of elements in S0 to S5. So now we can find the number of ways. So by addition principle, so take the sum of all this. So the required number will be 1 plus 4 plus 4 plus 0 plus 4 plus 8. So that will be equal to 21. So that is the required value. And the next problem is find the number of ways to choose a pair AB of distinct numbers from the set 1 to etc up to 50 such that modulus of a minus b is equal to 5 and modulus of a minus b is less than or equal to 5. So here modulus is always positive. So mod a minus b can be again ഈ കേസ് വരുമ്പോൾ 0 ആവാം, 0 1 2 നോട്ട് 0, എയും ബിയും ഡിസ്റ്റിങ്ക്റ്റ് ആണെന്ന് പറഞ്ഞിട്ടുണ്ട്. അപ്പോൾ 1 2 3 4 5. So we will see the first case where modulus of a minus b is equal to 5. So let me define the set Si to be the set of all AB where a and b belongs to 1 2 etc 50, and where a is not equal to b and modulus of a minus b must be less than or equal to I. Okay, Si എടുക്കുമ്പോൾ equal to I ആണ്. So mod a minus b is equal to I. Now the first case is find the number of ways to choose pair AB such that mod a minus b is equal to 5. അപ്പോൾ equal to 5 വരണമെങ്കിൽ so if you take 1 എടുത്തു കഴിഞ്ഞാൽ 6 വരണം, നമ്മൾ 2 എടുത്തു കഴിഞ്ഞാൽ 7 ആയിരിക്കും വരേണ്ടത്, ഡിഫറൻസ് 5 ആണെങ്കിൽ 3 എടുത്തു കഴിഞ്ഞാൽ 8 വരണം. സോ ഇഫ് യു ആർ ടേക്കിംഗ് 45 then it must be 50. ഇനി നമുക്ക് പെയർ ആണ് എടുക്കേണ്ടത്. സോ ദി order doesn't matter. So if you write AB is same as BA. So that order doesn't matter. You have to choose two numbers such that the difference is equal to 5. So this gives us all the required points. So you can see that there will be exactly 45 points. So cardinality of S5 is equal to 45. So therefore the required number of ways, so here the number of ways will be equal to 45. And now in the second part, the required number of ways will be cardinality of S1 plus S2 plus cardinality of S3 plus S4 plus cardinality of S5. So for S1 this will be the pairs. If you have 1 then 2 varanam, 2 3, then you have 3 4 4 5 and up to 49 50. So there will be 49 elements. അതുപോലെ S2 എടുക്കുമ്പോൾ 1 3 then 2 4 up to 48 50. So 48 will be there. S3 1 4 2 5 3 6 then 47 50. അതുപോലെ S4 എടുക്കുമ്പോൾ 1 5 2 6 then 46 50, and we have already seen S5. So add up all the cardinalities. So therefore required number of ways is 49 plus 48 47 46 45, so which is equal to 235. So these are a few examples of the addition principle. So in the next class we will look at the multiplication principle.